Hello, this section we're going to look at transformations of graphs. Okay, the first thing we need to do is be able to recognize basic functions, the basic functions that we're going to use as far as we go in this course. So, the first one is a linear function. It creates a line. Then there's the constant function that creates a horizontal line. An identity function is just y equals x, where you have 1, 1, 1, 2, 1, 3, and so forth there. Then there's quadratic function, x squared, your standard quadratic function. Looks like that, a parabola centered at 0, 0. With the vertex is 0, 0. A cube function, x cubed, looks like that. The square root function and the cubed root function. These are all standard ones that we'll be looking at throughout the course. There's the absolute value function, which looks like a V. Basically, it's y equals x, but since it's, that's not very good, since it's all positive, then those negative ones have gone up onto the positive part of the axis there. The reciprocal function, 1 over x, looks like this here. Okay, so there's several translations we're going to have here. So every single graph we look at takes one of those common graphs we call parent functions and moves it up or down, right or left, or vertically stretches or shrinks, or horizontally stretches or shrinks. Or it could reflect about the x or y axis. So, several different things that could happen to that parent graph to change it. And so, the first one we're going to look at is vertical and horizontal translations. So, a vertical translation would be up or down. And when we move a graph up or down, the equation for the function, we add or subtract c, a constant, outside of the f of x. So we're just adding or subtracting to the function. If we add, it moves up. If we subtract, it moves down. Just takes the whole parent function and moves it up or down. Horizontal translations, notice the difference here. The plus c and minus c are inside the parentheses, okay, with the x. So if we're moving up or down, it's outside, away from the x. If we're moving right or left, it's inside. Now, for up or down, if we added a constant, we moved up. If we subtracted a constant, we moved down. Inside the parentheses, for right and left, it is backwards. So if we add a constant with the x, we move left. And if we subtract a constant with the x, we move right. And you'll see what I mean by being with the x and outside as we look at some problems. So just keep in mind that left and right is opposite, while up and down is exactly what it says it is. So we're going to graph these functions. The first thing we're going to do is, in this table here, let's go ahead and list the y values for each x value over here for the parent function y equals square root of x. So we're going to be graphing first of all, g of x equals the square root of x plus 2. Notice my hesitation. So g of x is the square root of x plus 2. F of x over here is the square root of x plus 2. Okay, so I try to keep my hesitations in there to help you see what I'm talking about if possible. Okay, so as far as the square root of x, and we say that's the parent function because it's what hasn't had a transformation added to it. So the square root of x, where x is 0, y is 0. Where x is 1, y is 3. Where x is 2, the square root of 2 is approximately 1.4. The square root of 3 is approximately 1.7. And the square root of 4 is 2. So I'm going to go on over here, and you can see that it's already been graphed on my axis here. And very quickly, just so I color code everything, I'm going to make that purple. So okay. And then next we're going to graph g of x. So g of x was the square root of x plus 2. So basically we're taking each of these and adding a 2 to it. So we've got the square root of x, square root of 0, which is 0, plus 2 is 2. The square root of 1 is 1, and 1 plus 2 is 3. The square root of 2 was 1.4, and 1.4 plus 2 is 3.4. So you get the idea. Here we've got 3.7 and 4. So I'm going to take that over here, and we're going to plot those points. So we have 0, 2, 1, 3, and I'm going to stick to the nice pretty numbers if I can, and 4, 4. I think that'll suffice. And so we've got something that looks like this. And so you can see all these points have just moved up 2 places. Then we'll look at f of x, which is the square root of x plus 2. So what we're doing here, you can see how I was saying if it's on the outside, we're going to move up or down. If it's on the inside, that's with the square root, that's when we're going to move right or left. So this means that we're moving to the left, remember opposite, to the left 2. So we could just go over here and take all our points and move them to the left 2. So this one would go here, and this point would move left 2 here, and this point would move left 2 to here, and then we have our function. And so we could go over after that and say, well, we were at, it doesn't list -2 on there, lists some different numbers, but maybe you wouldn't even have to have the table. Or we can make the table. So what's happening here is in g of x, we had said the square root of 0 was 0, and then added 2 to get 2. Well, now we say the square root of 0 plus 2, which is 2. That gives you the square root of 2, which is approximately 1.4. And then we say 1 plus 2 is 3. The square root of 3 is approximately 1.7. Then 2 plus 2 is 4. The square root of 4 is 2. 3 plus 2 is 5, and the square root of 5 is approximately 2.2. And then we have the square root of 6, approximately 2.4. And if we go over here and plot these points, the only nice pretty one was 2, 2. But the other ones will fall in there too. So at 0, 1.4, there it is. At 1, 1.7, there it is. So that was a pretty good graph I drew, isn't it? Anyway. Okay, so you get the idea with moving up or down or left and right. This is another example of up, down, left, and right. So we're going to go through this one pretty quickly. So y equals, we have h of x is x squared minus 2, or k of x is x minus 2 squared. Again, you see outside means we move up or down. Inside means we move right or left. Okay, so 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and you can see I've already got y equals x squared graphed over here. Again, x squared is our parent graph because it's the main part there that's not having anything done to it. Okay. So we have x squared minus 2. Again, there's two ways you can do this. You can use the table, or you can take your points. We've got this point and move it down 2. We've got this point. This point here, we could move down 2. Same over here. And the point 2, 4, we could move down 2. Same over on the other side, and we'll have, not the best graph this time, our parabola x squared minus 2. Doing it with the table, we've just got our x squared, which was 0 squared minus 2, which gives you negative 2. 1 squared was 1 minus 2 gives you negative 1. 2 squared is 4 minus 2 gives you 2. 3 squared is 9 minus 2 gives you 7. And then we have 16 minus 2, which is 14. And then the other one, we've got, let's look at this one from the table first this time. So we've got x minus 2 quantity squared. So if we take our 0, 0 minus 2 is negative 2. Square that and we get 4. 1 minus 2, is negative 1. Square that and we get 1. 2 minus 2 is 0. 0 squared is 0. 3 minus 2 is 1. 1 squared is 1. And 4 minus 2 is 2. 2 squared is 4. So if we plot those points, 0, 4, 1, 1, 2, 0, 3, 1, and 4, 4. Then what has happened to our parabola? It has moved to the right. All the points have moved to the right. So again, that's where I said opposite in here. So since it was a negative in the parentheses, then we move to the right. Okay. What if we combine moving up and down with moving right and left? Well, so what is this done here? We've got our original function, This is our y equals x squared, graphed here in purple, our parent function. And then we're going to create a horizontal shift and a vertical shift. Okay, I think there's a list on here of what you want to do first. So there is a list in your notes. You want to do a horizontal translation first. So horizontal meaning right and left. Okay, so we want to take care of this inside, what's going to move it right or left first. So since we have a +1, that means we move left 1. Okay, remember on the inside it's opposite. And we could create a table here, but we really don't need to. We're just going to take all the points and move them left 1. Okay, and I'm going to do this dash since it's not the final product. Okay, and then we're going to take that and do our vertical shift, which is out here, -4. So with up and down, we actually use the negative as what it says it is. So down 4. And so we're going to take the pink one and move all those points down 4. And so there is our actual parabola, z of x. For example 4, same type deal. How do we identify the parent function? Well, what's going on? We've got an absolute value, and then there's some numbers, but we've got an absolute value of x. So that means that's our parent function. Y equals the absolute value of x is what I've got graphed there in purple. Horizontal shift, it says to do first. Since we've got a -2 inside with the absolute value, then that means we're opposite. We're going to move right 2. And then out here we're going to move up 3. And I'm just going to do this all in once. So I'm going to move right 2 and up 3. So next I'll take this point and move right 2 and up 3. I can use this point, move right 2 and up 3. And I think that pretty much suffices the absolute value since we've got a v there. And there's our p of x. Okay, shrinking and stretching. This one's a little bit trickier. So, vertically shrinking and stretching. When we vertically shrink and stretch, we're going to put a constant outside of the f of x. So just like when we moved up and down, it was outside. Then when we vertically stretch or shrink, up or down, stretch or shrink, it's going to be outside. So same thing there. When you multiply by a positive constant, then it's going to stretch your original. So you can see down here the black, it stretched it vertically. It made it stretch vertically. If your C is negative, then it makes it shrink vertically, as in that picture. Horizontal stretching and shrinking is backwards again. So, if the constant multiplies inside with the x and is positive, then it's shrinking. Or you could say it's happening more in the period than it was. If the C is inside and is between 0 and 1, okay, so it's not positive and negative. It's a matter of whether it's an integer or a fraction. So if it's an integer, oh, was that like that back here? Yes, it was. Crap. Okay, so let's go back and reconsider here. So if it's greater than 1, then that's when we're vertically stretching. If it's between 0 and 1, so if it's a fraction or a decimal between 0 and 1, that's when we're shrinking. Okay, so same thing here, but opposite. So if the C is on the inside and that constant is greater than 1, then we're going to shrink, as in this picture. Or if the C is on the inside and it's a fraction between 0 and 1 or decimal between 0 and 1, then we're stretching. So you can see how this was essentially pulled out, just like you would pull out a slinky or something. Okay, so let's look at some examples. So, first we've got f of x is 1/4 x squared. What's the parent function? Well, x squared. So y equals x squared is our parent function. It's going to be graphed in purple again, and here are the points that we're going to use. So 1/4 x squared, what happens there? Well, we take what we've got from x squared and we essentially divide it by 4 or multiply by 1/4. So 0 squared is 0 and 0 divided by 4 is 0. 1 squared is 1. 1 divided by 4 is 1/4, 4.25, however you want to write it. 2 squared is 4. 4 divided by 4 is 1. 3 squared is 9. 9 divided by 4 is, we'll make that as a mixed fraction, it's 9/4, but 2 and 1/4 will be easier to graph. And then 4 squared is 16. 16 divided by 4 is 4. So if we go over here and graph this, we've got 0, 0 still. And let's think about what should be happening here. Since we are multiplying on the outside, it's not included in the square like it will be on example 6. So I'm saying it's not like this, okay? Since it's on the outside, then that means we are horizontally, no, jeez, vertically stretching. And since it's between 0 and 1, we're actually shrinking vertically. So let's see what happens. So we've got 0, 0, 1, 1/4. I'm not going to graph that. So 2, 1, and 4, 4. I think that'll suffice because it reflects over here. And this is what we get. So it looks like it's been stretched horizontally, but instead it's actually, this has been squished vertically, okay? We've taken it and just squished it. I don't know how else to say it. Okay, so there's f of x. Okay, what happens when you multiply on the outside by a number greater than 1? Well, it's supposed to vertically stretch it. So, again, same numbers here. And we've got 4x squared. So 0 squared is 0. 0 times 4 is 0. 1 squared is 1. 1 times 4 is 4. 2 squared is 4. 4 times 4 is 16. And so forth. It gets big pretty fast. And so we've got the points 1, 4, 0, 0. And that's going to flip over here to be negative 1, 4, 2 also. And that's the only ones that are going to fit on there. And so what we have actually done is taken our purple graph, grabbed it up here at the top, and pulled it. And that has stretched it to give us our g of x. Oh, I had another place to graph it here. I didn't realize that. Let's do that. I guess you can see it a little bit better here. So there we go. And we've got 1. Oh. Well. I think the point I was trying to make here, let's leave that on there for now. But you've got a different graph too. Okay. So the point I was trying to make here is that it quarters everything. So what was 1, 1 now becomes 1/4 1. Okay, and so that's how it's squished. Okay, so moving forward, what happens when we multiply or divide inside with the x? So what's your parent function here? Well, your parent function is square root of x, okay? And square root of x, our y values were these. We'll go ahead and put them over here. Okay. And so for the one on the left, for r of x, it is the square root of 5x. So we're taking 5 times each x value and then taking the square root. So 5 times 0 is 0, square root of 0 is 0. 5 times 1 is 5, and the square root of 5 is approximately 2.2. 5 times 2 is 10, the square root of 10 is 3.2. 5 times 3 is 15. The square root of 15 is 3.9. And 5 times 4 is 20, and the square root of 20 is approximately 4.5. And so, over here, we can look at these. We've got that at 0, 0 still. 1 was at 2.2, so something like that. 2, 3.2. 3, 3.9. And 4, 4.5. And it's going to continue along like that. So you can see this time we have horizontally shrunk it or squished it. So we've taken this and pulled it back that way. Kind of imagine if you take, I don't know, like a gummy bear or a Krabby Patty or something like that and squish it. It makes it bigger vertically, right? Yeah, anyway. Okay, so what about the square root of x over 5. Well, this time we're multiplying by a number between 0 and 1, a fraction, okay? So this time we've got 0 divided by 5 is 0, and the square root of 0 is 0. 1 divided by 5 is 1/5. And the square root of 1/5 is approximately 0.5. 2 divided by 5 is 2/5. The square root of 2/5 is 0.6. The square root of 3/5 is 0.8. And the square root of 4/5 is approximately 0.9. So we can come over here and graph these. So we've still got 0, 0, and then we've got 1.5, 2.6, 3.8, and 4.9. So this time we have taken it and horizontally stretched, grabbed it right here and pulled it out. Okay, we're getting there. We're close to being done. I know this is a long section. For example 7, we're just going to use a graph that's already given to us and think about what's going to happen to it and graph it. Okay, so in this case, we have a graph here on the left, and what happens if we multiply inside, multiply the x itself, not the function, but the x itself by 4. Okay, so if you think back on your notes, if you're inside, then it's going to be a horizontal, let me make sure I'm saying it right, yes, it's going to be a horizontal stretch or shrink, and since it's a number greater than 1, then it's going to be a shrink. So we are taking this and we're squishing it in. So it's going to take up much less space. So this point, which was at x equals -3, is now going to be at -3 divided by 4, actually. And I know that doesn't seem like it from what there, it seems like it'd be multiplied, but it's not, it's going backwards. So we're squishing it in by 4. We're taking it into a fourth of what it was. Then the point here, a fourth of what it was, is right there at -1/4 1. This point is at where x equals 4, and so a fourth of that is right here at x equals 1. And then the last point is at 6, so that's now at 6/4, or 1.5. So right there. And then we connect the dots. So and that's what the graph of f of x in this case looks like when we multiply the x by 4. Okay, the last idea is reflecting. Okay, so this one's pretty simple. If you reflect outside of the function, then it flips about the x-axis, okay, in this picture. If you have the negative inside with the x, then it flips about the y-axis. So if we look at this example here, if we want to graph y equals -x f of x, then that's going to take it and it's going to flip it along the x-axis. Okay? And so all these points, the 0, 0 will stay, but the other points will come down here, like that. Okay? Do I have another page? Oh, well, wants me to do it here. Okay. There we go. And then this one is with the x on the inside, so that means it's going to reflect it about the y-axis. So these last two examples, we're going to take everything what we've just learned and put it all together. And this is where our steps come in, where what you do first is a horizontal translation. Then you do your horizontal and vertical stretch and shrink, do any reflections, and then last is your vertical or up and down translation. So first you go right and left, then you stretch or shrink, then you reflect, and then you go up or down. Okay, so let's see what we got here. What I'm going to do is I'm going to graph each of these dashed like until we get to the final one. So starting with our parent function would be an absolute value of x. And the first thing it says that we should do is a horizontal translation, so right or left. And so right or left is this x plus 1. Okay? So I'm going to be graphing y equals just the absolute value of x plus 1. And notice I don't have a table here. I'm just going to do it. Okay? So the absolute value of x plus 1, since it's inside, we do the opposite. That's telling us to move left 1. So we're going to take all our points and move them to the left 1. And so the first one that I've graphed here is just the absolute value of x plus 1. The next thing it says to do is stretch or shrink. So if we want to stretch or shrink, then we're taking into account the 2 out here. Okay? So now I'm going to graph, adding on to the pink one, 2 times the absolute value of x plus 1. Now what does the 2 on the outside do? Well, I just want to make sure. 2 on the outside vertically stretches or shrinks. Okay? And since it's greater than 1, then it's going to stretch, just as we would think it would be since it's on the outside. If it's on the inside, it's backwards. Okay, so it's going to vertically stretch. So what that means is the point that was here is going to be multiplied by 2. So it's going to go up to here. This point, since it's 0, stays the same. This point, since it's at y equals 1, is going to be multiplied and go up to 2. Okay? This point, let's see. Yeah. It won't get on there. So, but if we did, well, yeah, it will. So that's y equals 2. And if we multiply that by 2, it goes up to 4. And same thing over here. Okay? So we end up, after we've vertically stretched, we end up with this. Okay? Then the very last step is to add 3. And let's go back and write this. This vertically okay, so now we're going to add 3, and we're actually going to get our function with the 2 times the absolute value of x plus 1 and then plus 3. So we're taking the blue and moving everything up 3. So this one's nice and easy. And so our final graph is this red one here. And, you know, if all these others confuse you on your graph, or you're concerned about me being able to see which one is your actual one, you could maybe in mark, you know, make sure you do your ones in between in pencil, and then do the last one in a marker or pen and erase the other ones. Or if you just do the last one in pen and leave the other ones there lightly in pencil, I would get the idea. Okay, last one, example 10. So we've got z of x, which is negative 1/2 the absolute value of 3 minus x. Okay, the first thing we need to do is rearrange this deal. Okay, because we need it in the order of x plus or minus. Okay, so first of all, we'll just put x, the negative x plus 3. So that's saying the same thing. But there's still a problem here, because we can't have a negative just the x. It has to either go for the whole function or the whole inside. So in order to, I mean, it's not wrong, but in order for us to interpret it, then what we need is to factor out that negative, and if we do, then the 3 becomes negative, and that way we can interpret what it says and perform our transformations. Okay, so back through, we are first going to look at, is there any horizontal translation? Well, there is. Inside here, we've got x minus 3. I don't quite have room for all this, so let's move it around some. Put it up there. Okay, so x minus 3 inside means we move right 3. So the first thing I'm going to graph is just the square root of x minus 3. That's it. We're moving right 3. So all these points, I'm going to move to the right 3. And there we go. Okay? So next, let's see. It says to take care of shrinking and stretching next. Okay, shrinking and stretching, we're going to deal with the 1/2. So next I'm going to graph y equals 1/2. Notice I'm ignoring the x's, the negatives for now. of the square root of x minus 3. What does that do? On the outside, that means it's a vertical stretch or shrink. Since it's between 0 and 1, it's a shrink. Okay, so that means that where y is 1, it's now 1/2. 0 is still 0. Okay, and so we're looking like this now. Oh, I forgot to make those dashed. Better do that. Okay, so we've just pushed it down some. Okay, next is to take care of reflections. Now we've got 2 reflections going on here. We've got a reflection about the x-axis and the y-axis. So let's take care of our reflection about the x-axis first. Okay, and that's the one that's on the outside, this negative right here. So now I'm going to graph y equals negative 1/2 times the square root of x minus 3. And so that's just taking everything and moving it down below the x-axis. Okay? Then we're going to reflect. We're going to take care of the negative here. And that will be our last step. Okay. So, forgot to write down what these things were in here, so let's go back and do that. Give me 1 second. Okay. So, up here we had shrunk vertically. And here we reflected about the x-axis. And for the last one, we're going to reflect about the y. It doesn't mean that we reflect it all the way over here, okay? All the way on the other side. It means that we put an imaginary vertical line there and reflect onto the other side of that imaginary vertical line. So at this point, we'll just go over here, and now we've got our final function, the red one. And that finally concludes section 1-6.